Probably one of the most important examples will be found here with example 5. Notice that both equations are in the standard form. Usually, this is the way equations are thrown at you. You have to decide which equation you want to solve for, which variable is easiest to isolate. As you look at these 4 possibilities, the clear choice should be equation 1, solve for x. And so, equation 1, I'm just going to transform it. I'm going to solve for x by moving that 3y over. In other words, x is equal to negative 3y plus 4. Because I move this 3y over, it turns into a negative 3y. Now once I have that isolated, it tells me I can jump to the second equation, and everywhere I see x, I can replace it with this rule. And so I can say 2 times negative 3y plus 4, I'm replacing the x, minus 9y equals negative 2. I want to solve this equation. I just have y's there, and so I'll distribute and simplify. 2 times negative 3y is negative 6y. 2 times 4 is 8. This comes straight down, minus 9y equals negative 2. Simplify what I have. Negative 6y, negative 9y would be negative 15y. Plus 8 equal negative 2. I'll move that 8 over. As I move the 8 over, it's negative 15y equal negative 2 minus 8. And so negative 15y equals negative 10. Now I'll divide by negative 15. And I'll reduce. As I reduce, I get y equaling 2/3. Since I have a y value, I can plug this all the way back up top and come up with an x value. As I stated in a previous example, you're always going to have an isolated variable when you do substitution. This time I isolated x. When I isolate that, I come up here, I'm saying that the y value is 2/3. I can plug this right here and come up with an x value. So negative 3 times 2/3 is negative 2. Negative 2 plus 4 will be 2. And there I found my solution, 2 and 2/3. Here's an example where we isolated the x. And it'll be about half the time you isolate y's, half the time you isolate x. Here's a perfect example where you can look at all the equations and see which one's easiest to isolate. In this case, x was the clear-cut choice. Example 5. Solving systems of equations using substitution.